of Golang. So it was 5 years ago. So we created a powerful machine. And now we are sending it to the space. Because this is another graphic which was created especially for the 10th anniversary. So I can imagine next time when we meet, we should design and build a time machine. So this is, if somebody knows, the Doctor Who spaceship, whatever you call it. And I just want to tell you a few facts about Golang. So Golang was created in 2007. And to be honest, which is quite interesting that a lot of languages were created because people hated C++ or C, yes? So C++ was created because somebody from Sweden hated C. C++ was created, Golang was created because somebody hated C++. And that was the Rob Pike and Robert Greismer. They were waiting 15 minutes for C++ to compile, and they thought there must be a better way. So fast forward, 2009, we have pre-1.0 version, and that was the time that Rob Pike was going around the globe and was saying that, oh guys, I have this awesome language. Everybody should write in it, and it's so nice, you should adapt it, check it. And he spent like that almost 3 years, and in 2012 we had the version number 1. So if some HR will write you and ask whether you have a 10 years experience of Golang, then you know probably this HR person has no idea what she or he is talking about. So that was the first version. And just to not make it too long, 2015. And to be honest, I always thought that these Golang proverbs are from the very beginning. And today I just learned that they are just 4 years old, which is somehow I feel cheated because I thought that was the founding fathers woke up in the morning and wrote them down. But it turned out that is 2015. 2017, people got a little bit upset about GoPath. I think that was a very important moment in our lives as developers. Because I bet everybody here were starting writing Golang when GoPath was a part of our existence. And the best was when a new developer was coming from Java or from C++ and Python, and you had to spend 3 hours to explain him or her what is GoPath. And every time you finish explanation, he or she was looking on you like, what the fuck? And then, of course, that was the first day of Golang experience. Of course, after 2-3 days, the GoPath somehow get deeper in your soul. And to be honest, me now working with Go module, I feel a little bit sad because there's no GoPath. The sadness always fills my heart when I'm using the Go modules, which some people loved and hate. Regarding Go modules, that's 2018. Somebody from you remember the fight between GoDep and Go modules. And of course, we know who won and who got very sad. And now we are living in the reality of 2019, 1.13. So we have new errors. The Go modules are the part of the everyday work. So not to get too deep into the history. So here's where we are now. We have 28 Golang conferences around the world, 2,000 contributors to the language, 94,000 members of Golang meetups around the globe. Anybody knows where is the biggest Golang meetup in the world? No. Close. No, close. I have this IntelliJ license to give for a good answer. No. Indonesia, true. Jakarta. 14,000 Golang meetup members. 14,000, Jakarta. That's a lot. Yeah, that's a big country. And regarding Poland, here are the most popular meetups. 2 of them are semi-dead, and they're looking for somebody to revive them. So in Gdańsk, it's quite less active, and Poznań. But the Katowice, Kraków, Warsaw, and Wrocław are the most active. They usually have every month. So if you feel like spending a few days in one of these cities, you might always check whether they have the meetups on this time. So you can visit I think especially I like Kraków and Katowice. They have always quite interesting lineup, but I have never been there. And the conferences, we have two conferences, GoPerCon Poland and GogoConf. Somebody was on one of these conferences from here? Yeah, I was on the GoPerCon Poland. So the next year will show us which one will be bigger. I think there was a little bit like fighting between them. Okay, and today, because I really want to make it short, because we all came here for these two wonderful speakers, Tomasz and Ole, and I would like to give now voice to Tomasz, and that was all from my side. And during the break, we should open a beer and celebrate the 10th years of Golang. Thank you, guys.
Thank you, Wojtek.
All right. Hi, everyone. Here and there, the whole world. Mom, if you're watching me, be proud of me. So today we're going to talk about channels. Arek asked me half an hour. Oh, sorry. Arek asked me half an hour ago if I'm going to touch the basics on is there going to be anything interesting in my talk. So the answer is I'm going to touch the basics and it's going to be super interesting. So channels is when we think about channels, we think about concurrency, and this is very correct. And concurrency is actually something that brought me into Golang like 7 years ago. Just before the version 1 was released, when we were talking about the history, I took a look at Golang and was captivated basically by the capability of easily running the code on modern multiple CPUs. And if not Go routines, and same if not channels, I probably wouldn't touch it. So that's why I wanted to actually talk about it today. And I feel that we rarely actually talk on meetups about concurrency. Not sure why, because I think it's like the best feature of Golang. So let's start. At the beginning, some basics, some theory. Basically, this is from the Golang specifications. I took like two sentences. About channels. So one is saying. The very first sentence in the specification about channels is the channel provides a mechanism for concurrently executing functions to communicate by sending and receiving values of a specific element type. And the second sentence I found in the specification is that channels act as first in, first out queues, and basically the values are received in the order that I send. So what it tells us is that basically channels are thread-safe queues. We can use safely between Go routines, but they are not really only bound to Go routines. We could use channels just in a single Go routines. It probably doesn't make sense because we have a mutex there, and this was basically designed to be thread safe. But there's nothing actually special about channel that it must be used between Go routines. I haven't. So. Channel type. We know everyone probably know how the channel type, how we declare channel type. But I wanted to point out that actually there is more than one channel type. Actually, channels can be bidirectional or directional. So if we took a look here, we can define a channel that we can send and receive the values of type T. But it can. And this is bidirectional channel that we are usually using. But we can also create a channel that we can only send data to, or channels that we can only receive the data from. And this is how we declare it. Obviously, creating the channel that we can only send data to, or creating the channel that can only receive the data from wouldn't make sense. That's why usually we create bidirectional channel, and then we can simply cast into the specific directional channel. This is designed so if we have a function that only is supposed to read from the channel, we can basically just send a sending part to it, and it's safer then, so we know that that they cannot, for example, receive or they cannot send. So if we obviously to create a new channel, we have to initialize it. We are using the well-known make function, the built-in function that takes 2 arguments. The first one is a type we want to communicate, and the second one is the buffer. We can omit the second one, and then by default is 0. And except for the fact that the buffer will be 0, 1, or 2, or 3, there is a big distinction between having a 0 or zero size buffer and non-zero size buffer. Basically, if we have a 0 capacity, we are saying that the channel is unbuffered. And otherwise, if there is a non-zero capacity, the channel is called is buffered. And we rarely think about it, but it's very crucial to actually see what's the difference in there. Obviously, the buffer channel, we have some kind of array bucket up inside. We can store elements, and the buffer, an unbuffered one will not have. But what's more into it? So we should take a look again from the specification. What the specification say about being unbuffered and buffered? So the unbuffered channel So for the unbuffered channel, the communication succeeds only when both a sender and receiver are ready. This is different to the buffered channel, which the specification says the buffered channel communication succeeds without blocking if the buffer is not full for sending or not empty for receives. Now I want to focus more on the first sentence, which basically says that we can use the channel to synchronize 2 Go routines. What it means that if we have unbuffered channel and I want to send to a channel, like let's say I want to send this remote, I'm sending this remote to the channel, and I cannot just, because I have no buffer, I cannot just leave it there and go doing my own stuff. I have to actually hang out with my hand here in the remote and waiting for someone to take it. And only when someone on the other side will come over here and grab this remote from my hand, we can both continue doing our stuff. And this is different with the buffer channel, when I can just take the remote, put it on the floor, and go back doing my own stuff, and someone else can come whenever they want and pick it up and doing their own stuff. So we said the channel is a thread-safe queue. So with a thread-safe, not all the operations are thread-safe, but here is the list of the thread-safe statements we can use between Go routines without any further synchronization. So we can do sending, we can do receiving, and we can do calls to built-in cap and len functions. If you are familiar with channel, you can see that what we are missing here is the close. We cannot, close is not thread safe, which makes sense because you can only close the channel once from the sender side. So that's very good to remember. Let's see about sending. So sending, we know we are using this arrow thing that basically we are sending here the value 3 to the channel, and a few points about sending. So expressions are evaluated before communication begins. So if instead of 3 I would have a function here, the function will be evaluated first, and then we could, for example, block until we can send on the channel. This expression is blocking. If there is no one on the other side for the unbuffered channel, there's no one on the other side to actually receive it, we block it. We block until there is a room in the buffer for the buffered channel, or if there's a receiver on the other side from the unbuffered channel. 2 last points. Sending on the closed channel means panic. right? You cannot send on the closed channel. Sending on a nil channel blocks forever. And I would like to just stop on a bit on on the two last points, because there's a big distinction in there. Basically, do not disturb. So basically, sending on a nil channel does not panic, right? So if you, for example, think about maps, if you actually write to the nil map, it will panic. But on the channel, we can actually write to the nil channel. It will not panic, it will block forever. It's maybe something you don't want to do, because why would you block forever? But this is kind of not a bug. It's not going to crash your program. It's just going to block it. And sometimes you actually will want to use an expression when you want to send on the nil channel. And I will show you later when and why. Okay, after sending comes receiving. We have two options here. We can we can assign to a single value, or we can assign to the two values. The single value will just give you the value which was sent, and the second, if we use that two-value assignment, we'll get a Boolean value as a second one, and it will tell us if the value was actually like a real value which was sent to the channel, or it was just a zero value because the channel is already closed. So again, receiving from channel is blocking, and it blocks until there's something obviously in the channel. And as I said, if the channel is already closed, we can actually safely receive to the channel, and we'll get the zero value here for the type and the false as a Boolean value. So it's a little bit safer here than send, because we cannot actually do any panic on the receive side, right? Kaplan. So Kaplan was on the list of the thread safe statements, and maybe not all of you actually know that we can do cap and len. So what it does, the cap basically is like with the array. Cap will be the capacity of the channel, which is basically size of the buffer, and len will tell you how many elements are currently in the buffer, right? So if you run this, we'll basically see that capacity is 10, because we created this with the buffer channel with the size of 10, and we send a one item inside, and it's waiting for us to be received. And the last one is closing. So closing basically indicates that we are not going to send anything more to the channel. We can close only once. So if you try to close the channel twice, you're going to have a big panic. So let's see how, in this example, we're creating a channel of size 2. So there will be a buffer which can hold up to 2 elements. We're going to send 2 elements, 2 and 20. Then we're going to close the channel, indicating there will be no more items, and then we are going to try 5 times. We're going to try to receive from the channel, right? So a little bit more than we actually put inside. So cool, we got 10, we got 20, true, and then we just started to get zeros, right? With the Boolean false saying, oh, this is 0, you got 0, but it's actually not a real 0 that was sent. This is 0 that was generated by because the channel is closed. If we actually here, I can actually edit it, right? So also we got the panic here, because I tried to show you that closing it twice generates panic. So obviously we don't want to like iterate all the time. So you might think like, okay, I can use like this Boolean value to actually stop the loop, which would be good, would be fine. But we can actually do it easier and use the for range statement. The for range statement is similar to using with the array, slice, string, and map. It basically iterates over values in the channel, and it stops once the channel is closed. So it's very handy. Here we create a channel holding a time. The channel is buffered with 10. We want to fill the channel, so I'm just using a little trick here, saying write to channel until the length is less than capacity, so until it's not full. Then we're closing the channel, saying there will be no more data, and we are reading it back. So just take a look. We are not using any two Go routines, right? We are using this channel. Obviously, they're just examples, so they're not makes too much sense. But we don't need multiple Go routines to use the channels. And yeah, so we got all the 10 time values. We could actually see also how fast, for example, is inserting into the channel. We can see that actually we 1, 2, 3, 4, 5, 6. We inserted like 7 values within a single microsecond, right? So it's quite quick. You don't have to worry about that. Okay, so this is these are just basics. The not very interesting maybe basics about channels. Now I prepared for you like 3 programs, 3 apps that are going to use channels in completely different ways. So the first one will be counting prime numbers. So what we want to do, we want to create an application, a program, that is going to count how many prime numbers there is that are lower than number n. So our program will count prime numbers less or equal n. We are going to have one routine sending possible candidates, like numbers, to check. We are going to have multiple routines checking if these candidates are prime or not. And then we're going to have one routine collecting all the results from the workers and summing it up. We're going to use 2 channels. One channel will be for incoming jobs, this is here, and one channel will be for sending results from workers. So this is my image. Go routine, candidates, sending on the channel. Is prime, multiple workers checking if number is prime, receiving from the channel, and then we have one channel sending the results. Let's take a look at the code. This is just to show you that we have a function which is prime. It's just checking if the number n is prime or not. This is very simple. Everyone probably wrote something like that in the past. We're just going through all the number less than square root of the number n and checking if the modulo this number is 0 or not. And the main function. So we are creating 2 channels. The check is a candidate. There are the numbers to check, and the results is the results from the workers saying how many prime numbers every worker found. So we create the Go routine, which is going to send the numbers to be checked. I just took like up to 2 million. So I'm going to send all the numbers between 3 and 2 million. I'm only sending the odd numbers because even numbers cannot be prime, right? So a little bit of trick here. We're just sending to the channel. Once we are done sending everything, we close the channel saying no more things to check. Now we are running workers. So we define we want like, maybe actually I will, maybe not, sorry. So we define like 4 workers. For every worker we spawn Go routine, which is going to receive the items from the check channel, taking the candidates, checking if the number is prime, and summing up the results, right? And once we finish, so once the channel is closed, we stop the for loop and going to announce the number of found primes into the result channel. And at the very end, we need to collect all the results from all the workers. So we iterate, we know how many workers there are. We are going to sum up the results and tell you how many prime numbers we have found, right? So if we run it, 2 millions, we found like 148,000, like almost 149,000 prime numbers in about half a second. Now, just to show you that, if we change number of workers to like 1, I have 4 CPUs on my machine. We are getting the same result, but much slower, right? Like around 4 times slower. So we created a very nice, a very easy small app that actually is using all my CPUs to calculate the prime numbers. Now, one more thing I wanted to show you is, just take a look here. So this is the same program, finding the numbers. I created the candidates, the check channel. I created it buffered with the buffer size of 100. And the question is why I picked up 100 and not something else. It's kind of random, but I wanted to show you that if actually I make it unbuffered, the result is going to be the same. That's fine. This is correct. But it's going to be much slower, like almost 2 times more slower. And the question is why? Because, as I said before, the unbuffered channel is actually synchronizing things. So I have one Go routine doing very simple thing, but it's just giving me the numbers, right? The candidates. This is it. So I'm giving out I'm generating a number, giving out to the channel, saying, oh, here is number 3. And then I cannot just leave it there and take the next number and give it again. I actually have to wait for someone to pick it up. And I have, like, let's say four Go routines. One of them is going to grab my hand to take the number, and only then I can go back, take the next number, and give it back. But at the time I'm actually going back, all the 3 Go routines are waiting for the next number. So I'm just picking it up, next one will take it, and so on. Once I create the buffer, actually, I can just give all the numbers to the buffer, and then all the 4 Go routines are working all the time because there's already, the number being waiting there to being picked up. So if I don't add this buffer, I'm actually, I'm limited to one CPU generating the numbers. Now you can actually, try like different numbers here, like 10. It's going to be 800 milliseconds. So it's actually hard to figure out what the good number is because it depends how fast is the worker and how fast is the producer. The larger job to be done, the lower the buffer can be, and it doesn't actually impact this issue, right? If I do like a 1000, it's not going to speed up my program. It's actually going to go into some number like half a second here. So in terms of results, it doesn't actually matter because we only write like 4, if we have 4 workers, we only write like 4 numbers. So the whole synchronization thing doesn't actually matter at all there. All right. Now let's modify our application, and I actually don't want to have a counter and how many prime numbers there are, but I actually want to see the numbers. I want to see all the prime numbers. This seems like trivial thing to change. Instead of sending the counter into the channel from each worker, I just want to send the prime numbers. And that's true. That's the kind of only change, but the issue will be, I will go back now, the issue will be here. Because when I'm collecting the results, here I exactly know how many results there are going to be in the channel. Because there will be 1 per worker. Now if I'm collecting prime numbers, actually I don't know how many results are going to be. And if you actually remember, we didn't close the result channel here. The problem here was that we were taking the numbers from the check channel, and we can only close the channel once. So the question is, who is going to close the channel results? We have 4 workers. We cannot just pick one of them, because if we said like, okay, let's worker number 0 close the channel. The problem is we cannot do that because the channel could be closed before like worker number 1 finished their job. They would write into the closed channel, and we have panic. So the trouble here will be, if we don't know how many results there are, the trouble will be how to close the results channel. And this is why I introduced this example, and I'm going to show you one of possibilities how to close the channel. Basically, we're adding, in the sync package, there's a wait group. So what we are going to do is we are going to add every worker to wait group, and once, so this is adding, right? We're creating the worker, adding one, and for every worker, once the worker finishes their job, they're going to say to the wait group, okay, I'm done with working. And then we are going to spawn another Go routine, which is actually monitoring the wait group and waiting for all the workers to finish. Once everyone has finished their job, we can actually close the channel primes, saying there will be no more primes for worker. So this is the safe way of closing the channel. So amending the program this way, we can now use our range loop. We can actually now use the range loop and saying for every prime we found, print it out. I modified the program to just look into up to 100, so it doesn't spam me out with 2 million results. Interesting part, obviously, here when we talk about concurrency is they are not actually in order, right? Because one worker can be more lazy, slower, faster. So we have to realize that once you put this into the multiple workers, they are not going to go back to you in the same order you were sending them. But yeah, we got all the prime numbers smaller than 100. Another app. A little bit different usage of the channel is, let's try to create a semaphore. The semaphore is like a mutex, but with, you can specify a number. So basically so the idea is that you can only, for example, allow up to n numbers of Go routines doing one thing. So here we are going to create an application, the program that is, that multiple Go routines want to work on a specific task. And we only allow up to like 2 or 3 routines working on it. So it's like a non-standard way of usage of the channel, but I just wanted to show you how that you can think out of the box and using the channel this way. So here's the function, it's a task. So do something, right? This is a task. And this is the implementation of semaphore. So the semaphore will be a channel with a size of 2, saying I will allow up to 2 Go routines working on this task. And in order to acquire the semaphore, we are going to send, okay, so this is the empty structure, right? So we are not going to pass any meaningful values to the channel. We are just going to fill it. We're just going to operate on the fact that the channel is full or not full. So in order to acquire the semaphore, we are going to send an element to the semaphore. If it's successful, that means there was a space in the buffer, and I can work on it. And once we are done, we are going to take the value back from the channel, and here's some work, which basically means that only up to two Go routines are allowed to run this code, and all other Go routines are going to hang here waiting for their turn. And this is run the workers. We're going to run 10 workers. In the loop, they all want to do a specific task, right? So if we do run, we'll see it starting, and we'll see that here's like a task ID, the worker ID. We see like that every second, because it takes like 1 second to perform the task, every second like 2 different workers were able to work on the task, right? So sometimes actually we can see things like that in the code, that people are rate limiting specific part of the code using channels. If it's a good idea or not, it's a different thing, but you can do that. So the question is now, can I do the semaphore non-blocking? Means I don't want the workers to wait here hanging until someone else finishes the task. I just want to either acquire the task, acquire the semaphore and do the task, or just tell me I couldn't acquire it because someone else is working on it. Yeah, so we can do it using the select. So we haven't spoke about select before, but now we can see. So the select can take multiple cases, or in this case, 1 case. And if in terms of in terms of the channel, if the channel is ready for communication, then the case will be run, right? So if I can write the element, send the element to the channel, then I will execute this part, which means, okay, putting it, and then I have acquired the semaphore, and then I will release the semaphore when I'm finished. Default part will tell me that if I couldn't actually do anything here, go into default part and return false. So very simple change, but we created like a non-blocking semaphore, which makes the function return false if I couldn't acquire the semaphore, and true if actually I work on the job. So here is a simple example. The same thing, we are 10 workers running in the loop. We try to do a task. If we did it, we just say task done. Otherwise, we say that we would block and actually we are doing something else. So if we run it, we see that like almost everyone is doing something else. But from time to time, two Go routines actually perform the job on the task. So cool. Nobody is hanging. Nobody is waiting. Everyone can do some meaningful things. But actually, if you want a semaphore, you can use the one implemented not on the channels, but in the maybe more correct way, using the xsync package. And the last one, the most interesting for me, almost real life, because this is something I'm running in the production, maybe a little bit more complicated, but quite similar. So we want to write a scheduler. The scheduler will be something that takes tasks or jobs on the channel and spit it out in different order according to some priority. So we are sending tasks to the channel, receive task from another channel according to some priority. So this is not like a simple first in, first out queue, which is done during a channel, but we want to add some reordering. We are going to hit just two channels, incoming and outgoing, right? So we're going to send task, we're going to have a scheduler, and we're going to receive tasks in some other order that we can define. And when for the first time, I needed actually something like that in the code, and I was thinking how to solve the problem. So I was thinking like, okay, I have two channels. One is for receiving, so I'm thinking of how to implement scheduler. I have one channel for receiving items and one for sending, right? So maybe I'll run two Go routines. One Go routine will be receiving the items and writing it to some queue, and the other Go routine will be taking from the queue and trying to write to this channel. The problems started to arise. How do I synchronize the queue? And what happens if the queue is empty? Then the one sending the items here needs to stop. And then once it stops, the Go routine here would need to wake it up once there's a new item in the scheduler. So things got complicated. I had like two screens of code, and it was buggy, it didn't work. So I just removed everything. And I was thinking maybe I can do it easier. So yes, we can do it easier using only one Go routine, and quite nicely. So let's start. This is our main function. We have two channels, incoming task and outgoing tasks. First, we run a Go routine which is going to simulate jobs for us. It's going to write 10 random numbers. The numbers will be between 0 and 1000. Then we are going to run a scheduler, taking in and out the channels. And at the end, we want to collect all the numbers from the scheduler in the main function and print it out. So I will tell you that for now, the algorithm of setting priority is the higher the number, the higher the priority. So ideally I want to get the higher numbers, right? So if in the scheduler we have like 1, 2, 3, I want to get the 3 first, then 2, then 1, right? So we don't have scheduler yet. I'm just going to show you that it works. I'm sending random numbers. I get it back in the way I want, except for the first item. We can talk about it, why the first item is weird later, but pretty much this is what you want, right? They're random, but they are coming back to us according to some priority. Okay, so how to write the scheduler now? Let's first create some queue. This is like a helper function, helper type, which is going to keep the jobs for us. The job for us now is just an integer. So this is a priority queue, right? So you're going to add to the queue means we're just going to append to this to the slice and then sort it. So we always keep the integer sorted. It's not the best way of solving it. There's a much better algorithm to solve it, like using heap or some other ways, but it just keeps it simple for the sake of the example. So we're adding to the priority queue, we sort it, and we know that the largest number is at the end. So the top will return as the top element, the higher number, which is basically the last element on the queue, and the pop method will remove the last element. Very simple queue. And then, scheduler. So the scheduler will take the incoming channel that we can receive from and outgoing channel that we can send to. We have this queue that we're going to keep all the elements. And then we have a loop. The loop says that we are keep looping until there is something in the queue or we expect something more to get. So the incoming channel is not nil. So then I create the variable xout. I call it xout because the xout variable can only have 2 values. It's either out, the same as out, or it's nil. And it's out if there is something in the queue. So if there is something in the queue waiting to be delivered to someone, I'm going to have a non-nil value in the xout. Otherwise, if the queue is empty, I'm going to have it a nil. Now, why I want to do that? Because I'm going to use a select here. And in the select, I have 2 options. One option is try to send something, and the other option is try to receive something from the incoming channel. And I spoke before that you can send to a nil channel, which means it blocks forever, which means the channel is not ready for communication. And if the channel is not ready for communication, the select will never pick it up. So this is the case that we actually are sending to a nil channel, trying to send to a nil channel, but select will never, actually, it's just like we'll ignore it. We don't have to do any ifs, anything. It's sorted out by the select. So it means that if there is something, if it's not nil, which means there is something in the queue, which means we will take it from here. Once it's sent, we remove the element from the queue. And the second case is getting the incoming elements, which basically is we read the element from the incoming channel, we take the element itself and see if it's close or not. If the channel is not closed and the number is real, we add it to the queue. Otherwise, if the incoming channel has been closed by the sender, meaning there will be no more items to be delivered, we send the incoming channel to nil, which again, if you go back here, will just ignores the whole case here. Because the in channel is empty, you can receive from the nil channel, it will block forever, because it means the channel is not ready for communication. If the channel is not ready for communication, the case is not going to be run at all. So basically, we like switch here between the cases which we want to run. And yeah, that's it. It's very simple. It's very simple, and it works with one Go routine and not too much code, to be honest. So again, this is our code. Why the first one is different and weird, like not in the order? It's because we created like the scheduler. So this is the most probably the very first number that was generated. So we just put the number. We generate number 196. We put it into to the channel, and there's immediately someone who is receiving it. So we don't need to do any sorting, because basically this is like the maximum number at the point that someone is receiving from the channel. But because then there's some backlog going on, and the workers are quite slow because I added like a time slip over there. So items are coming into the channel, and then there's sorting, and we get the items in the order. So interesting thing, for example, here is that if you wanted to modify, so if you think about it, we're just adding to the queue, and it's unlimited, right? If the numbers are coming in, we'll just add to the queue, and it's unbounded. And what if we wanted to, for example, say that if we already have like 100 numbers in the queue, we don't want to receive them anymore. Just block the sender, saying there's too much. We need to wait for some workers to do. So it's not too much you actually you have to do. You can do the same trick here. Basically, we can just put the mic on. So we can just do like X in. I'll just make some tricks here. So I have a X in being so X in will be the variable which assign the similar to X out the in channel. But if length of queue is larger than, in this case, I will do 4. Okay. If it's larger than 4, then we are actually doing a nil here. I'm doing it in one line because it's tricky to do multi-line. So again, and I need to modify here the in to X in. And again, so here if we have more than 4 elements in the queue already, we are going to set it to nil, and we will stop receiving the items. Then if we do the pop and will be less than 4, we'll go back here and we'll start receiving the numbers, right? So we could, for example, let's try to run it. So it's not now clear, maybe from example, it's hard to illustrate, but you could actually see now that they are kind of like ordered, but only in the clusters, right? Because, for example, here it's like 4 numbers here, 4 numbers here, because once we started to write numbers into the queue, it said like, okay, stop, enough. I have enough of your numbers. So we started to get them back in this here, and then this. So yeah, very nice trick with the. Remember the trick about the nil channel. It will save you a lot of code. So that's it in terms of the programs I have. And for the homework for you, I wanted to make you think about other users of channels. The interesting ones will be broadcasting. So you want to send a value to the channel and receive the same value by multiple Go routines, right? How would you do this, right? So obviously you can use multiple channels and so on. But there's very nice, interesting case about waking up Go routines. Imagine that you have like one channel, and you have multiple Go routines. Every of those Go routines is waiting on the same channel. And there's nothing there. They're just hanging, blocking, waiting for something. And how can you wake up all the Go routines at the same time? Because if I just send one item, right, only one Go routine will pick it up. Is there any way, do you have any idea how I can just wake up all the Go routines, like do like a signal, like a broadcast to everyone saying, wake up people, let's do your stuff. Yeah. It's like a one-off operation, right? If I close the channel, actually all of Go routines would start receiving value 0, and they would wake up at the same time. We cannot reuse really this later, but it would work. Another useful way of using channels is asynchronous function calls, where you can, for example, for our workers, you could send a job, and instead of waiting for a job for the worker to return immediately, you could actually send the channel within the job and saying, hey, once you figure out what the response is, once you've done the task, please send me the response to this channel, right? And you can just wait for the response somewhere else in the in your program. So no examples here, but I encourage you to sit down and try to figure out and use the channels this way. Yeah, thank you. If you have any questions, I'm happy to answer. Hopefully you learned something, at least one thing, from the basics about channels, and happy to help.
So guys, we have to give away IntelliJ license, so I need two more questions from you. Yes, that was one question, so one license, and I have 3 which expire tomorrow, so they are like for instant consumption.
Everyone knew this stuff.
Yeah, to be honest, I really like Tomasz talks because he goes to the basics, and when you hear him, you're like, oh, I should have known that. I mean,
I think the trick with the nil channels.
Yeah, it's really nice. This one.
It's really good, and I actually learned it after a long time. It's very useful.
Okay, I need one more question. Come on, don't be shy. Huh? Who needs the license? Okay, so we can figure it out. So done. Oh, 3 licenses also, because the story is like that. I applied to JetBrains. The guys are amazing because whenever you do the meetup, they give the license for free, and I forgot about it. And I have like licenses for 4 meetups in my mailbox. So it's good. 1, 2, 3, 4. Just approach me after the meetup. Now we're going to have a 15 minutes breaks. Grab a beer, grab a water, grab a coffee. We have also a lot of beer without alcohol because I know some of you came here by car. So just enjoy. And after in 15 minutes, we will have the second talk. Enjoy, guys.
Okay. Okay, hello everyone. I think this is not quite often when the girl is speaking over here, so I will just do it gladly. So I want to welcome Ola Bulbuk. This is a Berlin Meetup Golang organizer. And when we decided with our GogoApps team to rejoin the Warsaw Golang meetups, we thought that we would really like to invite some nice speakers and also to build more up our community. And that's why I contact Berlin Golang meetup. And here there is Ola who contact me as well. He's one of the organizers, and I asked him. He works with Go since 2015. So the first version of Go was 1.4 that he used fully. And today we decided, also I made a little survey within Wojciech and Arek and the other, and we asked for the topic Tales from Event Sourcing Pastures. So welcome, Ola.
Thank you. Thank you. First of all, I have to admit, I'm not the only organizer, right? Natalie is really our main organizer, and she's not only organizing the Go Meetup, but as well the Women Tech Makers and the Go for Europe conference. Must be really bad news to him, but so yeah. Tales from event sourcing pastures. So, you know this, you are working with old technology all the time and you are craving for greener pastures a lot, right? And event sourcing and CQRS have always been thought to be this really nice, fancy thing that you would like to do because Google and Facebook and also on are doing this, right? So I want to take a closer look at this tonight and would like to get to know you a bit better. Is anybody working for Google or Facebook or something like that? Microsoft, Amazon, one of these really big, scaling endlessly companies? Okay. And but who is using event sourcing or CQRS? Someone? Okay, cool. And who knows the concepts behind it? That okay, a couple. So, but I should still try and explain a few things. Okay, I won't make that too long, but I hope you can understand. And if not, please ask a question, right? Otherwise, it won't be so much fun for you the rest of the talk, because this builds up a bit. Okay, let's start. So, of course, first, what is event sourcing? So, instead of just storing, should I make it a bit bigger? Okay, I try that. Sorry. So this looks better? Okay, cool. And still the whole slide on there, cool. And yeah, so you store events like what has happened, and so you don't store like an entity like a bank account, for example, but you store the event that somebody has opened a bank account. And then you later build on top of that, like somebody paid some money on this bank account and then received some money from somebody else and sent a few euros away to a third friend and so on. but you don't store the balance there, right? So you only store the events, and the current state you calculate by looking at all the events, and then you know in the end what the true state is. So this is the big difference. And so you should choose events from the real world. And some people do events like create account, update account, delete account. And then you quickly get, in an elegant way, the downsides of both worlds, right? This is not so good. You want natural events that describe what has really happened, and not something that is technical. And you will understand soon, I think. So, and events are history, right? So you shouldn't rewrite it, you shouldn't want to change it, really. It has happened, and you can always add a new event that undoes something, but events have happened, and so you should live with that somehow. And let's see what upsides do we get. So Event Store has a nice property that it is really kind of a database, just with a single table more or less, and it can be used as a queue at the same time. So you can subscribe for new events, and you can the events are stored there permanently too. And events are replayable, so you can start from some time in the past and say, give me everything that is newer than that. And so you got traceability, because you can really see how things have developed, and this allows deterministic error analysis. So you can, if the system misbehaves, you can just replay everything and then see, there it went wrong, and so on. And you can really understand how things developed, and this can be really nice. Unfortunately, the whole thing has a downside too, right? You can't change history. And it feels sometimes like in a straitjacket. And so there is not much tooling around in open source tooling or so. So if you are Google or Facebook or something, they have great tooling, right? They have people there, whole departments who just do tooling. And they can write something that gives you the best of both worlds, but it's not easy to get that. And especially when you use as an event store something like a queue, like Kafka or something like that. And another downside is, especially for Kafka, lack of good hosting. For relational databases, you can get them hosted everywhere, like Postgres or something. This is really easy to get. And for Kafka, we've been looking for that, and it's really hard to find someone. And if you find someone, they usually say, yeah, you can use it. We offer it, but please don't store data permanently in there. Kafka that we offer is thought as a normal queue where you put things in and other people get things out, but it should be removed, and it's not for permanent storage. And the latency is usually quite high, so it's not easy to get really good hosting for that. So we get more downsides. technical changes, right? You shouldn't rewrite history, but sometimes you have just a typo in there, right? And other times you have events that where you have usually sub-entities. There's always the question, if I have one thing that relates to something else, do I store the other thing in there too? Do I have fat events? Or do I just store the ID and have lean events? Lean events are, of course, much quicker to communicate, but sometimes you miss something important. And this can be can change, that you first think, okay, I really need a lean event because this is everything and I got the ID in my local store anyway. But later somebody else wants to use the same event for something else and he would need the fat event. And then you can't change it anymore. And there are other things. Yeah, we're getting more serious now, right? Yeah. So if your company wants to do pivoting, right? You just change your business model a bit. You have real hard problems there. We've been fighting that back, that we couldn't do anything about this. And one downside that we are still fighting with, or that company, is cutting events in a different way. Like if you had done this with updates and deletions and create and so on, really CRUD operations as events, we can't change this easily. This is a huge thing, and you have to rewrite like almost 80% of the software just to get that right afterwards. And then, this is still not the last thing, yep. Which way you, in which style you designed them. So if you say somebody paid some amount into a bank account, or whether you say update bank account with this information, and then you give all the data that the bank account holds. Right, and the natural event would be saying somebody withdraw like 100 zloty, and the other one would be an update of the bank account to 200 zloty or something, right? And so this can lead to almost a rewrite of the more or less the whole system. And the last thing that is really evil too, there's this GDPR, General Data Protection Regulation law. I don't know whether you know it. I can read it here. So this is about privacy and so on, right? The data privacy and the right to be forgotten is very central to it. And this makes really trouble, because more serious infringements go against the very principles of the right of privacy and the right to be forgotten, which Event Store really is. And that are the heart of the GDPR. Fines up to 20 million euros. Or 4% of the firm's worldwide annual revenue, blah, 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 right? So, whichever is higher. So, this is something you don't do often, right? And, I mean, this is really all just one downside, right? If you have all the tooling, like you have 10 millions to spend to rewrite old events nicely and delete events and so on. This can work very well for you, but if you don't have it, you should be really careful. So let's take a look at CQRS, what this is, because there it really makes the most sense. This is a graphic of a traditional implementation that doesn't really use a good event store, even though there is an event store graphic there, like this one here. But it should really be here, right? Because the event store can act as a queue and as a database at the same time. And this guy would have to get this two consistent, right? And you don't want this. You want a real event store that can be both. Otherwise, you write there and can't write notify the others because you don't write to the message queue or the other way around. You never get consistent. So and a real event store is really good to have there. But apart from that, the CQRS system is relatively simple. You have commands, it's called. These are the writes. Everything that changes something in the system goes here, like open an account or so. And then the command is processed, stored, and then there will be more stores where you can read data from later, and they process these events, and then, for example, the account balance can be stored there, and that can be handed out very quickly to the readers then. So the good part is when you use this, that the writers and the readers are independent, and especially the readers, they can have a store that is perfectly designed for them, and they can very quickly pick up the data and hand it out immediately without many database joins or big calculations or whatever. This can be really, really great, especially when you do very complex stuff there. Right, so yeah, in a couple of minutes I will talk a little bit more about that. Let's see, so this is the principle, and this makes a lot of sense then. And let's see, so the upsides are of this. You have now a clear specification how to cut microservices, how to split a monolith into smaller things, right? You have these command services, you have these query services, and then some transformations in between, and so on. So you get a quite good idea how to split your big system into parts. And another upside is new query stores can be invented later. So if you later have an idea, you can just create a new microservice, and then with its own store, and then make it get all the events from the past. It can read everything, and then you have good store there. It can hand it out quickly again, and it can be very creative there, and it can be independent of all the other things you build up already. You can see this quite well, I think, on the Amazon websites. When you look at a product there, there are all these suggestions and whatever, and there are different lines, some with things related to the article you chose, some things related to what you have bought before, and then some other you don't know what it's really related to, but it should be interesting to you. And so on, these are all things where they can put in a lot of machine learning and whatever stuff that can take a long time, and can be totally independent of you buying something, but you can get optimal offers there, and it's not consistent perfectly, but who cares, right? If you get the optimal offer from an hour ago or something, right? Nobody can prove anyway that you didn't get your perfect offer, right? So there it makes a lot of sense, and when they get creative and finds a new way to sell you something, then they can just add it later. So, and this gives you quite endless scalability, right? Especially for the reads, since they are stored in an optimal way, you don't have to do much. You can just hand out the data quickly, and this is really good. That's why Google and people do this, right? And even the writes can be made fast, depending on how much you need to do validation, but sometimes it's okay to just receive the data first and do the final validations later. You just do like syntax checks and so on, the simple ones, and other checks you do later, and then you can still say, sorry, this can't proceed any further because we found some error there, right? And this is of course perfect, like for these Facebook, Amazon, Apple, Netflix, Google, and so on, right? Microsoft should be in there too, I think, but whatever, right? I don't know where you're working at. So this, for these big companies who serve like not only millions but billions of users, that makes sense, right? Then you have to scale for the full internet, and then this is the only way probably. But let's see. It requires a lot of hard to get or create tooling, especially in the Go world. We don't have much tooling for it. The Java world is much better there. Even .NET has much better tooling for it. And in the Go world, we have a lot of cloud tooling and so on, but not really for this CQRS pattern. And often you split things further because you have multiple command services and multiple event stores, and then you want to combine events into something new, and these are often called then reactor services and so on, and then you have these projectors that write multiple events to these stores that the readers operate on, and so on. So this can be quite a lot. You can split a monolith in very small parts, but this can easily become more than you like to manage. And of course you don't have just one query service, but usually many, right? You want to have perfect performance for all the different views that you want to have on the system. So and this is of course the nice thing. You can be creative, you can always add one, but you have to maintain all of these, right? And so it can be really many, and complexity can grow a lot. So if you have really something, a simple domain with like accounts and then transactions on those, or something like a shop or so, this is usually not what you want, right? Except if you do this big machine learning for perfect suggestions and so on thing, right? There it makes sense. But for the simple stuff, where reading a traditional entity from the database is just as fast as reading an event from the event store, there's not much difference. You don't gain much, right? And so the biggest upside, of course, is developer happiness, right? Because we all would like to work for these cool companies or want to be at least part of the cool club and show that we are good enough for it, right? And yeah, that's of course when you do it already, you are one of those, and you can write famous blog posts too. Yeah, finally you have something interesting to say and so on. And yeah, of course you will be invited to the big shiny conferences in the US and become a star, and your next employer most likely, of course, somebody like that will value your experience and will love it. And if your company really has to scale like crazy, of course, this is the best, you saved them, and this is, you did the right thing from the start, right? But yeah, you look like the next Steve Jobs almost, right? But reality is not exactly like that, sorry. So in reality, it's a big ego trip, right? If we are really honest, except when you are one of those companies or something, or a similar situation, then it's usually the company will blame you later that things are far more complex than somewhere else, and you will never write that cool blog post because it's just not that cool, and yeah, you won't get invited to any conference, and yeah, unfortunately, future employers will smell it and say, oh, for that company you use that. Maybe not really what's useful. And so what is useful instead? So you want to understand why CQRS is good and scaled so well, so that you can work with it. And you want to prevent to do the opposite, right? You don't want to do anti-CQRS where you join like 50 tables and then calculate complex things and then do machine learning on that and whatever, right? And read some more tables or so. This will take too much time, right? But you want to do this in a bit more intelligent and natural way, maybe. And what often is sufficient is when you have normal entities that you use status columns and use them a bit more deliberately, that you have a status like received data. And later you can validate and say it's accepted. And then you can have more fine granular things. And you don't need to you don't need different stores for that, right? And you can subscribe to database changes. So Postgres is quite good at it. At the company I'm working now, we are using Postgres as a queue, and it can serve quite a lot of, couple of thousands records per second, and this works astonishingly well. And there was a blog article about this, how to do this exactly, just a few weeks ago. If you want to know more, I can dig it up for you. And and of course you can use extra tables, right? If you, instead of a full event store, you store something first in a extra table and then work asynchronously on it until you can save it to the database the way you really want. Then you have kind of a mini CQRS there, but it's you don't have the full-blown thing everywhere. Oh, pizza is coming, and now it's getting interesting. And yeah, you get at least around 90% of the CQRS scalability, of course, depending on the complexity that your domain has, but usually you can serve up to multiple 100 million users. So there are, I think this UK bank, I don't know the name currently, sorry. They use this, they do this, and they still have a lot of microservices and so on, but they don't use CQRS. And so, yeah, and you can have, of course, more junior developers inside the team because you don't have to explain all the concepts and so on behind the thing. And the manager still needs you, right? Because you, if anything goes wrong, he still needs your expertise and so on. You don't have to worry that you get fired or whatever, because now all the young people or right inexperienced people are good enough to do things. And other thing is, a good manager might let you work instead of doing complicated things for the company, in the company, and making things more complicated than necessary, might let you work on open source instead. There you can work on interesting stuff. A good thing is, if you want to ask for this, to suggest that you will work on things that is used by the company anyway, like Kubernetes, Prometheus, or whatever and cloud technology you are using, or if you are working with Postgres and want to scale a lot later, maybe CockroachDB might be interesting or something. There are a lot of open source projects that might be interesting for your company too, and then you can get a good compromise there, and you don't make things more complicated than necessary for future generations, but still have real fun and can do a good contribution and be really valued. So biggest upside is, your developer happiness, hopefully, right? Because the company works then like most companies would like to do, right? So they all would like to do something nice, technical, but easy to maintain too. And of course it shows you're good enough for them, right? And you can still write good blog posts, right? Maybe not the very fancy one, but still really interesting stuff. And you can still speak at conferences, right? Maybe not the one biggest one in the world in the US or something, but maybe a lot in Europe or wherever, right? And your next employer will value your experience. Even Facebook and Google and stuff, when you can explain them why you didn't do CQRS, but something else would be has been more efficient, and that shows that you understood the concept and so on. This is very valuable for them, right? They know, okay, you are not a big ego type or something, or want to do things only because they are fancy, but you really think, what are the requirements? And this is important to them too, of course. Yeah, and if your company has to scale, you still know in quite adequate way where you can scale step by step, and so you can still be quite of a bit of an hero there. And your open source know-how, if you manage to build that up, can be really handy if problems with the project shows up, right? So nothing better than having trouble with something and then having a committer sitting in the back on the same project and think, oh, now we can talk to him, right? And even if it's not a core committer and can't fix the error himself, he can know at least how you should report a bug and make other developers quickly jump on the problem. He knows how to approach them and the best communication channel and so on. This can speed up things tremendously. So you can still become a hero even if you are only a small contributor to this open source project, right? Yeah, and if you help others, like more junior developers, this is still a good way to get promoted, right? I mean, it's one thing to tame computers, but making other developers, working with them nicely together is not easy either. And if you can do this well, this is really good. And then you have a good chance to get a promotion there. So thank you. That's it. And now let's have pizza, right? Yeah, please. I didn't get the question completely. So you had one NoSQL? Mm-hmm. 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 Ah, yeah. Yeah. Mm-hmm. Yeah, I mean it can go both ways, right? I mean, one machine with all the data can be very simple because otherwise being consistent with doing changes to multiple databases can be much more challenging, of course, especially if you want to be consistent in between and you can't shut down the system or something. But the other way around, if you do something like SAP, they have like, I think, more than 8,000 tables or so in the relational database, then it's way too much, right? This is going crazy, and you can't build the whole world in a relational database, right? Sorry. That's too much, but you have to find a compromise that works nicely for your domain, and you have to cut the system into maybe not tiny microservices or something or databases, but things that are naturally belong together a lot and things that are more independent of each other, and then it's much easier. But this is always very domain specific, and only experience can show what works well. I've been using Kafka before, but now we are using Postgres. So, okay. Yeah, you know, it's a very advanced system, but you have to know all the details how to use it and all the cooling. Yeah. Yeah, true. In the old company, we wrote an own Kafka driver to get around some things, but maintaining a Kafka driver can be really awful after a couple of years. So, yeah. Mm. Mm. So I would really start with Postgres. This was quite a good decision from the company now, and it scales relatively well for quite a while. And you can later, I mean, you already have this command store, right? And all the structure, you can exchange it with another store that is writing to Kafka or whatever else later. This is not simple, but if you need to scale, then you will have the money, right? Then you can spend like 10 millions or let's say 5 maybe for really good tooling. But before that, it will cost you and it will be very difficult. Yes. This is more this topic around like event discovery or event type discovery, or that you know what events are available and where to get them, right? That you ensure that you get all the events, not the sequence of events, but that you get all the kinds of events that you need, right? Did I get that right? Okay, yeah, so of course you can start simple if you only have a single command service with or a single event store with one queue, then this is trivial, you can get everything. But of course, after a while you want to split to make this more scalable. And yeah, there you have to again domain knowledge and see how you can split this in a natural way that these are as independent as possible. Because if you have multiple event stores, it's not trivial to get those consistent in any way, right? You can try with event times or something, but this is no fun, because times and computers is not a trivial thing. If you want perfect ordering, this will never work. So pizza time.
So guys, we can enjoy pizza. I just need 3 minutes from you guys, okay?